This example is going to show how to automate some system study scenarios using the IEEE 39 bus test case, which actually comes with both EMT tools that we're using in this bootcamp and many other tools that you have probably seen. So there are 10 generators in this test case. One of these, I believe it's this one, is actually representing an equivalent to connections to the rest of North America. This is kind of representative of the New England test case. The question comes up, what size IBR should we be looking at, and what location? So in our I2X project, which is sponsored by the DOE Wind and Solar Energy Technologies offices, called I2X, we have a little project and tool set for exploring the impact of different ways of looking at bulk electric system hosting capacity. So it is based on MAT power and doing some optimal power flows. If you're interested, you can look at the link there. There's two links. One is a description of the MAT power version of that test case where we can do load flows, and then how we come up with a proxy for hosting capacity. So it is based on an N-1 contingency analysis at constrained optimal power flow, and we kind of guess what is the injection capacity each bus. And what we came up with is the lowest one that's not zero is at this bus 14, right in the middle. And so there are 3 lines serving bus 14. Notice there are no generators there. So the evaluation is based on taking those lines out of service one by one, and some other contingencies in the system, but the local ones tend to have a lot of impact. And we came up with a hosting capacity of 369 megawatts. So what that says is, based on that kind of rough analysis, is that an IBR project size of 369 megawatts ought to fit there. So we chose 300 megawatts at bus 14 to take a look at. Interestingly enough, the analysis for bus 19 came up with a hosting capacity of 0. And if we look at it, there's local generation. There's two local generators there, but the only other branch at bus 19 is this line to it's bus 16 there. So with the N-1 contingency analysis, when you take that line out of service, there's no way that a new generator at bus 19 can export. And the assumptions we made is that some existing generation, some of this will have network interconnection service, the NRIS, and so a new IBR here at bus 19 with N-1 contingency analysis would not be able to export. So ways around that, the system could be strengthened there. They may call for ERIS, the Energy Resource Interconnection Service. But anyway, for the purpose of this bootcamp example, that's how we came up with bus 14 and the 300 megawatt size. So it wasn't completely arbitrary. The load flows we did in MAT power for this. You, of course, will be using something else, for production grade work. In the virtual session on September 14th, we went through, for each of the tools, really some detail on how to get load flow dispatches into the EMT tool. So I'm not going to repeat that in this example. That recording is available, or will be available, on the NERC website. So if you didn't see that, I would suggest you go look for it on the NERC website. But the focus of this example is really how to automate the contingency analysis for different, once the load flow dispatch is set up, we want to do faults and clearings in and around bus 14 with this line out of service, and then again with this line out of service, and finally with this line out of service. And the fault is going to be right on the terminals of the line, right outside of bus 14. So for example, right here, right there. Okay, so we'll do that fault with both of these other 2 lines in service and with one of them out of service. And so when we set up an N-1 contingency condition and we take the second line out of service, there's only one line there to export power from bus 14. So it is another line coming out of service from an N-1 condition. So it's fairly severe. But we want to set up some scenario where maybe a plant that looks like it would fit based on a hosting capacity analysis result wouldn't really when you did a detailed design study or interconnection study.